Everyone who is attending, thank you for popping by. I guess this is the third webinar in a series of webinars we've been giving here at Arthur since I think December maybe was the first one. I gave one last January, and now we're going to have one today focusing on the use of workflows in agentic design. If you have any questions, feel free to drop them into chat. I have the Q&A open here on a monitor. I will try to answer questions live. It can be a little bit hard, obviously, if the questions are very long, though. And then we'll obviously have a little bit of a chat at the end of the webinar. So thanks for joining. Great. So a quick structure about what we're going to talk about today. First, I'll start with some opinions about how to think about agentic systems. These are becoming sort of the agreed upon ways of thinking about agentic systems. I do want to say, if you want a deeper dive into some of the science and R&D behind what's led to where we are today with agentic systems, multi-agent systems, and so on, do check out the last couple of webinars we gave. I do a deep dive into basically the history of AI from like 1957, 1958 onward, and how the definitions of like AGI and agents from a computer science point of view gel or don't gel with the way people are talking about AI agents these days. So I'm not going to do that in this webinar, but I do encourage you to kind of go on a trip down memory lane with those past webinars. I'll then talk about using workflows to help control and empower and evaluate what people are calling agents today. We'll talk about ways to guardrail agentic interactions, both with other agents as well as with sort of the dynamic world in which we live. That could be the internet, that could be your email, as well as with humans. And then I'll talk about some common risks that we're starting to see pop up, especially in enterprise land, and some advice for mitigation, not solving, but mitigation of some of those risks. And then, as always, I'll leave you with some current thoughts and gaps on what we need to do in the coming year. Great. So again, drop chat questions if you have any. Quick overview. What's an AI agent? There is a traditional formal definition of an AI agent. I go over this in the last webinar as well, but I really want to sort of pound this point home because this is not a new concept. Okay, so in general, an AI agent needs to do each of these four things. It needs to perceive the world in which it is. That could be your desktop screen. That could be your phone screen. That could be the actual physical environment if we're talking about some sort of embodied AI, a little robot rolling around. It needs to learn from its interactions with the environment. So for those of you who are following the sort of reinforcement learning hype that has really gone up since the DeepSeek R1 release about a week ago at this point, the learning that's going on there is learning to do a better job of spitting out sequences of tokens based on interactions with some a virtual environment. Okay, and so I'll define what that means as well. Ideally, you want some sort of abstraction of the world to be formed, maybe like a world model, and you want to be able to generalize using that model to do well on tasks that you, for example, weren't trained to do. And then finally, you are going to act in that environment, right? And this could be taking over your mouse and clicking on things in a browser, or this could be, literally self-driving in a car or something like that as well. So it's these four things: perception of the world, learning from your interactions with the world, being able to generalize. So I'm not going to be taught how to do every single thing. That's obviously intractable. And then being able to actually act and sort of reason upon what's going on in the world. I realize it's very abstract, but this is what an AI agent is. Franz asks, how do agentic systems help in robotic arm movement use cases? Yeah, this is like a classic use case, right? And robotic arms are probably a lot further along than many people think they are. But the way one might train an arm, for example, to do like inverse kinematics, which is to say, I want to, I have multiple actuators on my arm and I want to get the arm to be, in a particular orientation over a particular part of the world. How do I, apply various physical forces to the arm's various, say, joints and rotors and all that kind of stuff to get it into that point? You can actually learn that via virtual like simulation. I can do a digital twin of that arm, and I can, over time learn to select basically a policy that takes it from one orientation to another orientation. And so there you're going to have perception of the world, which is going to be, what are my angles and various like physical forces for my arm right now. You're going to learn from that virtual environment typically. You're going to generalize. You're not going to learn every single point and every single mapping of A to B, right? You're going to be able to learn a general policy from that. And then the reasoning and acting here is perhaps a little bit less important. I mean, acting is like applying physical forces and so on, but it's less, I think, less AGI feeling, right? But yeah, that's a direct mapping there. Great question. So I do want to give you a concrete instantiation of what modern sort of AI systems look like. We're going to have a human, and the human's going to give some sort of task, right? And for now, I'm just going to focus on like text to text, right? So this is like you're interacting with a traditional chat GPT, which isn't going to be able to like spit out images for now, but all of this is going to generalize to any of those other modalities of input and output data. Okay. So I'm going to give a task to a system. I'm going to type into a chat box or whatever and say, hey, I would like to analyze this data, right? I will upload like a CSV file and I want to, figure out averages and maxes and mins and so on from the columns. That's going to go to an agentic system, which is going to perceive sort of where it is in the environment right now. And right where it is in the environment right now is it's taking that task as input, and maybe it's going to do something to tokenize and figure out things with embeddings and so on. It's going to sort of like place itself in the world. Okay. So that I should probably have these be 2 arrows here, but that's going to be from the multi-agent system itself. Based on the task and its perception of what the task should be, it's going to reason about what to do next. Okay. This could happen multiple times. It's going to reason, maybe it's going to actually do some sort of exploration or like hit like a vector database or something like that of your private information to do a little bit of learning about something or another. And then it's going to keep thinking about this for a while before finally taking some sort of action, which could be like searching the web. It could be something like deploying a particular workflow, which I'll go into later in the webinar. That action, for example, like hitting the web, is going to interact with some sort of virtual environment, including the internet and your browser and Google and whatever other sort of actors you want to have there. You're going to get some sort of output from that, and you're going to have to think about what that output means, represent it in a particular way, which would be the perception step there as well, and then learn from that and sort of repeat this until you spit out your answer. The multi-agent system spits out an answer or a candidate answer. The human maybe potentially looks at this and says, hey, no, that's not good. And we iterate again. Or the human says, hey, yep, that's good. And we call it a day. Okay. So I'll go over a couple other sort of reference architectures that we're starting to see in the multi-agent space. But I just wanted to sort of map this common architecture into those 4 boxes that I showed on the previous slide. So, if you talk to me sort of offline, you'll hear me be a little bit cheeky about some of my thoughts on AI agent sort of hype and marketing, but it really is sort of if you squint, an instantiation of the true general AI definition that has been floating around for well over half a century at this point, which is pretty cool. So I'm pretty excited about this. Great. So yeah, I didn't really talk about in that agent architecture abstraction and generalization. And so we'll touch on that a little bit more in the future. But there is sort of an assumption there that I can take my system itself is going to be able to take some family of tasks and do a good job answering those questions, right? And so when you talk about like a ChatGPT or like a DeepSeek or like the Anthropic models, these are truly meant to be general like foundation models, right? That can then enable general agentic systems. So they're meant to generalize to different tasks. But as we're seeing in the enterprise, a lot of companies are doing verticalization around specific like industry verticals, or even they're doing specification of their agentic systems into like HR tasks or into engineering tasks and so on. And so those are explicitly meant to be less general overall, right? They're not going to be as good at planning your vacation or something like that, but they might be more efficient or even better at a subset of those general tasks, like engineering tasks or HR tasks and so on. So we're starting to see some design patterns emerge here in agentic AI. And one of these is called reflection. So if you've used, for example, like O3 Mini, which OpenAI just dropped, or if you've used like the DeepSeek models, which you can access via like Together AI or via Azure or via Amazon and so on, then you're going to see some form of reflection in like the thinking tokens, like it'll think forward and think backward and things like that. This is pretty cool. So it's a way to sort of try out a particular path of reasoning, and if that path doesn't look like it's going to end well, I can try a different path instead. Tool use is table stakes at this point. In fact, I'll go into what I hear people calling an LLM these days. They're just assuming that you're able to use tools like call out to the internet, call out to Python code, call out to Wolfram Alpha, and so on. That's very different, by the way, than, for example, when ChatGPT actually did launch in late November of 2022, so like a mere 2.x years ago, this idea of tool use was not implemented, right? And so this has moved very, very quickly. Multi-step planning, we'll get into this a lot more with the agentic systems that are going to be able to compose workflows to create a general plan to solve a task. and even multi-agent systems. And so we'll get into some of those reference architectures as well. We might have specialized agents who are able to do specialized things very quickly, like somebody's very good at searching the web, somebody's very good at reading CSV files, etc. So I'm taking this from Anthropic, but this is widely seen as a good differentiation between two related ways to enable agentic architectures. One is something called a workflow, and this is going to be a human-designed set of you can think like building blocks that I can put together to manipulate inputs to create a final output. And that might involve multiple LLM calls, but it's going to be a fixed flow of information from the input to the output. And I'll give you some examples here. I went over these in the last webinar as well. So actually, my last webinar, somebody in the Q&A said, hey, this sounds like if this, then that for AI. And I actually kind of like this as a way of saying this, where I'm going to predefine the sort of flow of information in my if this, then that. And I'm going to be able to enable an agent to dynamically select from one or a subset of workflows in real time to try to achieve a task. Okay, so the difference here is workflow land, a human came in and specified a flow of information from an input to an output, whereas agents are going to be able to dynamically create that flow of information via tool use and via composition of these workflows and so on. Okay, so agents strictly more general than workflows in the sense that we're empowering in real time a computer to do more things than with strict workflows. So the thesis of this final webinar for the agent stuff is that agents can use workflows as tools, basically, to accomplish a task. This is hard to argue against because we're seeing it in practice across the board. And that workflows are going to provide human-created and understandable hard constraints on agentic behavior. Okay, and so this is going to say, hey, if I define a workflow that says, I can only, for a particular type of task, I can classify that task. And if it's something that is quote unquote high risk, then maybe I'm only able to hit a particular LLM that is known to be less risky than some sort of easier LLM, something like that. That's a hard constraint on the way the agent can, for example, select an LLM. And that hard constraint might be, useful for you as a developer when developing, say, evaluations to see how well your system is doing. You can now look at these workflows and sort of like, click and drag them around to enable or not enable the agent to do things. And B, it might be required by the internal governance at whatever enterprise you're at before deploying the system, right? And this will be important for liability reasons. And one of my predictions for 2025 is we're going to start seeing some best practices in that space emerging. So I want to do a quick overview of a couple of workflows that we're starting to see, and then I'll talk about how we use these to empower agents after that. So the first thing that I want to talk about here is that, I'm a scientist. I can be very pedantic about things. I won't be pedantic about this. When people talk about LLMs, large language models, a model, these days, they mean something like more of a LLM++, I might say. So we're assuming as table stakes, when somebody says LLM, that we're able to do some sort of RAG call to a vector database, right? We're able to call out to private information that you've uploaded in some sort of easily searchable, maybe vector database. The LLM is going to be able to call out to that and do some sort of augmentation. It's going to be able to call out to basic tools, right? So all of the leading open source models and all of the leading closed source models have basic tool use baked into them. Tool use, again, is going to be something like calling out to search or having Python executed in a sandbox, something like that. And people are even starting to, as table stakes, assume that we have some sort of short-term or long-term memory that the LLM is able to call out to. So for example, with a ChatGPT or something like that, we're going to assume that there's some sort of long-term knowledge that's being like a knowledge graph, for example, over all of your chats that tells a system kind of like this is how the user is interacting with the system over time. So as a scientist, this annoys me that this is actually still being called an LLM because I would actually call this a system that is enabled by one or more LLMs, but this is generally what people mean when talking about LLMs these days. So a raw model basically with some extra bells and whistles. Don't yell at me when I use this as LLM then. So one quick workflow. This is a very, very common one. In fact, this is so common that I would say it sort of exists before people started thinking about it as a workflow. It's something called prompt chaining. I won't go into this in great depth. I do this in the previous webinars, but the thing to really pay attention to here is that bottom picture, okay? This is basically a predefined flow of information that takes from, for example, a human or from another agent, some sort of input, and then summarizes or thinks about that input, does some sort of gating function and says, hey, like, I don't think this needs prompt chaining. Let's just fail out quickly, or calls out to some other sort of flow of LLM calls to get a final output. Okay, so that's an explicit creation of this graph, but the information is changing dynamically via, for example, traditional machine learning calls or calls to a vector database or calls to an LLM as it flows through that graph. And again, a shout out to a lot of the open source tooling here. DSPy, if people haven't played around with it, is a really cool prompt optimizer, and it's going to shine in a place like this. Another extremely common paradigm of workflow is basically routing, right? So there are companies that are based on this. This is basically saying, hey, I'm going to see a task come in, and maybe I'll pass it through a traditional machine learning classifier, or maybe I'll pass it through a summarization Gen AI model, and then route to a particular LLM based on maybe how hard I think that task is, or maybe what type of task it is, right? Is it a vacation planning task? Then go to my vacation planning specialized or fine-tuned model. And if it's a coding task, then go to my coding model and so on. Okay. And these can also be routed based on things like cost and latency. And we're seeing that a lot. This is one of my predictions for 2025 as well, is that we're going to start seeing a lot more optimization of the space. Another very common one that we see actually in real life, but also in agent land, is basically parallel querying of a number of LLMs and then forming some sort of voting mechanism that either chooses the best of all these results or does some sort of aggregation or summarization step before moving that information forward. So again, explicit graph saying information comes in. I can choose to enact one or more of these paths to LLM calls, and then I have some sort of explicit aggregator that takes that information and passes it on. Workflow number 4. This is an extremely common sort of baby's first multi-agent system workflow where we have some sort of orchestrator, which is going to break a particular task into subtasks and then call out to different, maybe specialized LLMs or sets of LLMs to solve those problems and then do some sort of synthesization of all of those inputs into one final output, or maybe some sort of aggregation, much like in that voting mechanism I talked about before. And you'll see this with some of the agentic designs around like AutoGen or around Magentic 1 or around like Crew AI or some of these labs that are doing multi-agent system generation. Yeah. And then finally, a really common one that we're seeing in practice is what I'll call peer review here. You can think of this like an auditor. You can think of this like a judge and a jury, something like that. But it's basically I'm going to have some sort of loop that takes as input initially a task, spits some output out, and then before returning that output down the line, it's going to actually have that output be evaluated by some other model or even by a human. And then the evaluator is either going to reject it or again, give some feedback and then have the LLM try again, or it's going to pass it forward and move it on out. Cool. So, coming from academia, this might be something like peer review. Coming from industry, this might be something like red teaming and so on. Ooh, all right. So that was a whirlwind tour, about 10 minutes of these different workflows. Again, I encourage you, if you want a much deeper dive into those, to look at our last webinars. But again, the TLDR here is that workflows are these systems where LLMs, traditional machine learning models, calls to databases, whatever, and tools, calls to the internet, calls to your email, are orchestrated through predefined code paths. So the information is going to flow in a predefined way from input to output. So generally, you can imagine optimizing and choosing these automatically before giving them to an agent, but generally these are going to be predefined by a human and then given to one or more AI agents who can dynamically choose to use them to accomplish a final task. So I'm going to take a quick pause there. I don't see any questions in chat yet, but if that is not clear to anyone, please feel free to just say something in chat and I will address what you say. Great. So let's give some agents access to these workflows, right? So as a recap, human gives a task, agent system starts to think about what that task looks like. That perception step, that thinking about what the task looks like, how to represent it, and so on, I can use one or more workflows to do that, right? As I'm reasoning about the task itself, I can use workflows to do that, right? As I do this over and over again and choose my action, that action can be a composition of tools and workflows as well. This goes out and goes through some sort of simulated environment. Here we've chosen Factorio, and comes back into a perception step, which says, hey, I acted in this world, and now I think I'm in a new place. Well, how do I figure out where I am now after that action? That's something that could use tools and workflows as well. Okay. And then finally saying, are we done? That are we done could be using tools and workflows as well, right? This could be a human now using workflows that are predefined and choosing basically as an agent, as a human agent, to evaluate the output from this multi-agent system and decide to go forward or not. So at every step of this, you can imagine composing tools and workflows and so on to create what to do next. So just to visualize that toolbox that is given to an agent is going to have all of these workflows. These are the 5 that we just went through: the LLM router, the prompt chaining, the wisdom of the crowds, the orchestrator paradigm, and that evaluator, right? That peer review, and anything else that you might define on your own, by the way, right? So your enterprise might not allow some of these. Your enterprise might force some of these. You might have your own sort of, weird toolbox of workflows as well that are predefined. We're going to give it access to some tools, right? This might be like Python code, Wolfram Alpha, calling out to Perplexity. And we might even be able to call out to humans, right? I could actually do like a Mechanical Turk or like a Scale AI call out within these workflows itself, right? And that's obviously going to introduce some latency, but that could be one of my tools, is calling out to a human to get an evaluation or to get some sort of data labeled. The agent is given access to these and then dynamically chooses which ones to use. So here's another common paradigm for agent system design. And I'm using this now instead of the one that I defined, just to give you that sort of extra guarantee that I'm not just making all of this up. So I took this one from Amazon, from AWS. So it's very similar, where basically the user passes in some sort of task. The task goes through maybe a classifier, a task-based classifier that then selects one or more agents from a set of agents to do some sort of processing of the task, and maybe loop a bunch of times or spit out an output. Okay, so this is, I would say, a slightly less general form of agent system design than what I went through. But you can imagine how you could extend this into a multi-agent system, for example. Now, this is coming from Amazon, and I want to highlight a couple things here just to begin with. So one is this initial task coming in, going through a classifier that chooses an agent to use. Well, that feels a whole lot like routing, right? So they're using the phrase agent here because the agent's going to be able to do tool use, workflow generation, and so on to solve a problem. But it's the same general workflow as the LLM router that I went through before. So that's cool. So what would I call this that we're looking at right now at a high level? Well, this is the workflow that was defined by, in this case, somebody at AWS, or knowing Amazon, like 15 people. It's a workflow that it's predefined the flow of information, and that workflow itself is using as sub workflows some of the workflows that I went through already, like that router, or like in this case, agent processing. This could be using peer review, for example. I could have some sort of processing that spits out an output, and I'm going to ask an LLM, hey, is this good enough? And it's going to keep doing that until it is good enough and passes out a final answer. Or because this is coming from Amazon, it could literally be calling out to mturk if you wanted to do that to ask for advice from a human. So this is pretty cool. Generally, if you start thinking about things like workflows, you can start thinking about anything in agentic design as the generation of sort of information flow graphs, right? And here's an explicit example of what I mean by composition. I mean, this is also an explicit example of composing multiple workflows to form a final sort of mega workflow, if you will. Here's a more explicit one. I could, for example, combine wisdom of the crowds with something like multiple peer review execution. So what do I mean by that? Well, this is that same figure that I showed in wisdom of the crowds, where we have some tasks come in, and then we have kind of a jury of LLMs that each give their own response, and then we aggregate their responses or do some sort of voting mechanism. Well, that jury could be, in its own way, some call out to multiple calls to peer review, for example, right? So I'm going to say, hey, for my OpenAI based LLM, it's going to call out to some system that tries really hard 4 times to create the best result possible, and then spits it back out, and then I'm going to aggregate those results as well. And I could do that for LLM call 2 to Anthropic, and LLM call 3 to Meta, and so on. Okay. And so this is great. And we could actually have an agent that decides whether or not to do this composition in real time based on perceived difficulty of the task, right? That initial input to the wisdom of the crowds workflow. So I'll take a quick pause there again. And if there are any questions, feel free to drop them into chat or any sort of like workflows that you're seeing, for example, in your own job. Nothing yet. Great. So in the last like 10 minutes or so of this webinar, I'm trying to keep it a little bit shorter this time instead of going the full hour. I'd love to go over some of the deployment challenges and risks that we're starting to see. And again, I'm super optimistic on all of this stuff. I'm really excited I'm giving this webinar in early February 2025. I think we're going to see a lot of movement in 2025 in this space. So I'm really, really pumped about that. George says, just letting you know it's interesting and helpful. We are all here. Thank you, George. Love a good audience support. I want to go through some of the challenges that we're seeing here. And I'd love to hear from Chad as well what you're running into. So one that is, Franz asks, yeah, before I go into this, let me answer this question. Do you think having multiple smaller LLMs versus multiple agents is better in terms of executing workflows? Yeah, so Franz, you're kind of getting ahead of my very last slide, which is basically like, you should use the amount of power that you need, right? So an agentic workflow is strictly more general and thus more powerful, but also thus more potentially expensive and also thus more potentially risky or harder to evaluate than one LLM or a set of LLMs, right? Like the agent itself is going to have access to at least one Gen AI-based model internally. It could have access to multiple smaller LLMs as well. So I would say, for example, if you have a task that you can define very clearly, that workflow, for example, I don't know, you're trying to figure out the stock price of a particular ticker symbol, and you have some sort of LLM call that hits Google, an LLM call that hits Perplexity, an LLM call that hits Bing, an LLM call that hits DuckDuckGo, and so on, and then you do some sort of voting mechanism from there. I don't think you need agentic anything for that, right? Like that's just using tool use. But if you had something more, I don't know, more complicated, like a financial question about computing, I don't know, the risk of some sort of complex portfolio and doing some sort of like dynamic optimization or something like that, then maybe you would want to go up to sort of a full agentic system. But the basic response to a question like what you're asking is that, you should use just as much power as you need, right? So you might not even need Gen AI in general, right? If, for example, you're asking questions about ticker symbols and prices, like you can just hit an API for Google Finance and get that result back. And it's going to be way cheaper and also more correct than an LLM-based method. So, you should just use as much power as you think you can. It's going to be easier to evaluate if you do that. Brian Russett asks, curious especially about challenges in interacting with external systems, for example, enterprise databases that are under existing business critical load. Yeah, that's a great question as well, Brian. So there's sort of two external system risks that come to mind immediately. One is what I might even call the easier one, which you're talking about, which is I have some sort of internal system where the data, the inputs to that system, what's stored in that system is at least nominally controlled by not an adversary, right? By your enterprise, right? I'm not inserting, prompt injections into the database necessarily. Instead, what I am doing is I'm potentially enabling a system to increase load substantially on that enterprise system, right? I don't want to like DDoS, for example, my internal data like DBMSs using a multi-agent system, which could absolutely happen, right? I could absolutely have multiple evaluator paradigms, that peer review paradigm for say 100 different agents, and every one of those has to do some sort of complex SQL query on some sort of internal enterprise database, and you basically, well, that's not good for you and your job. Yeah, cost and evaluation there is going to be a huge one. And yeah, frankly, what you're going to need to do is, and you'll see some of this in some of the slides I'm going to go through, is you need to just put guardrails on calls. You need to be doing evaluation of not just individual calls, individual parts of those graphs that I was showing you, but the system in general, right? Because at this point, it is some sort of automated system that's just going out there and doing things that you don't necessarily know how to predict, right? Because you're enabling it to choose live. So in some sense, like a lot of the controls you would put on just traditional programs, you would put on these as well, like cost monitoring and so on. Two, in terms of external data, right? Like you're also calling out to the internet or you're calling out to your email to do some sort of like summarization task for what your peers have been talking about or your Slack or whatever, right? Adversary John, can email you something and I can craft that in such a way that I might try to manipulate your internal agent, which is hitting your own email or the public internet to do bad things. And we're already starting to see this happen. And to be frank, like this is an unsolved problem. So as a quick aside there, Anthropic, I think yesterday, so Anthropic being one of the frontier labs, like they're the best of the best, they put out a defense against what are called universal jailbreaks. And jailbreaking is basically a way to get a model to break its alignment and start saying naughty things or whatever. And so Anthropic, a leader in this space, put out a defense against universal jailbreaks that was broken in, I think, 11 hours by Pliny the Liberator, who's like one of these people on Twitter who just does an amazing job of jailbreaking models. So if you have an adversary who is sophisticated enough, for example, a nation state or some person on Twitter, right? Then you can insert these sorts of attacks into external data that's then going to be hit by agents themselves, and then that is going to bring that external data potentially into an internal system, which is very, very, I won't say scary, but it's an attack vector that exists. Pradeepa, what are the best practices for validating outputs generated by AI agents to ensure accuracy and alignment with intended goals? Are there specific frameworks or techniques you recommend for automated versus human validation? Yeah, so evaluation and guardrails, it's a very important space to be in. And so, Arthur offers products in this space. There are open source products in this space. The hyperscalers, the CSPs offer products in this space as well. And so you are going to want to select a couple of things. So one is like general sort of guardrails, right? So these are going to be things like in the hallucination detection space for a particular task, potentially. You could also have homegrown detectors internal to your own systems. And then I'll get to this in the coming slides, and actually maybe I'll stop answering questions for a bit and get to them in the coming slides. One issue that we're seeing is that with agentic systems, you now have error propagation, right? So we're going to have sequential actions, these compositions of workflows. And if I get something wrong up here, it might have downstream impacts in ways that are going to be harder to evaluate. So instead of just watching over individual, chunks of that path, the inputs and the outputs, like with traditional LLM firewalls, you're actually going to need to watch over the full combination of these interactions in these systems, right? So for example, I might have an agent that misinterprets, I don't know, some sort of like internal date that says, I want to find the stock price for this particular date, February 29th or something like that, right? And I get the year wrong, and February 29th doesn't exist. And I do a query to a database somewhere downstream, and I get no results back because I'm not in a leap year because I misunderstood a request, right? That's multiple steps down the line. And so watching over that is tricky, right? It's going to be more expensive. There's obviously this combinatorial explosion of like things that you need to watch over. And so I would say a lot of these are going to have to be coupled with some sort of like in-house design. Yeah, it's an amazing question. So mitigations here, like you shouldn't stop doing what you should already be doing, right? Like we have a product called Shield, which is an LLM firewall that validates inputs and validates outputs. You should keep doing that, right? Like every one of these inputs and outputs to traditional machine learning, to agentic systems and so on, like keep watching over that. You can do more explicit guardrails as well, right? So for these workflows, if I have a predefined workflow for example, portfolio optimization, I might know that some particular chunk parts of that path, edges in that path are, they're about dollar values. And so maybe for some of those dollar values, I should not allow a negative response to come out, right? So maybe I can't have negative money in my wallet. I mean, obviously you kind of can, but maybe I'll have a hard constraint there, right? And a big one here is also like if I can do some sort of confidence estimate as to, the confidence surrounding my result that pops out of, for example, an LLM, then I can have a fallback mechanism if that's below a particular threshold, right? So just like with traditional, say, LLM systems, if I have a low confidence result, then maybe I dynamically choose to use that, evaluator workflow that I talked about to try and get a better result, or maybe I actually call out to a human to get that result verified at high cost. Access control. This is a big one, and this is kind of getting to the question that was previously asked as well. These agents are going to be dynamically selecting workflows. Those workflows themselves are, defined by a human, and you can do, traditional sort of like you can't access this system by just not drawing an edge between A and that system. But it's hard to actually, or can be hard to track information flow as I dynamically generate these workflows, right? And again, in the same way that errors can propagate, information by design is going to propagate far downstream. And so that information, for example, if it was relevant for a particular task and that agent should have had access to it upstream, that information is still going to be in the system, potentially in memory or something like that, for a task later that maybe the agent shouldn't have access to that information for, right? Like maybe if I'm trying to personalize an email to a person, I'm able to get their personal their PII, right? Because I have to say, hey, John, here's X, Y, and Z. Now, if that PII then gets stored in memory, well, now downstream, I might have something like make a public post about salaries or something like that. And now we know John is associated with a particular salary, and that's PII leakage downstream, right? So you need to be able to look at, almost like RBAC for agentic systems is like very hard to do. And there are these new attack vectors. I already went over this, but like these are explicit attack vectors that exist online, poisoning attacks for the public internet, or poisoning attacks basically for internal systems that you might have by injecting data onto the internet or into your email and so on. So some mitigations here. These are very similar to mitigations you might take designing, enterprise access schemes for humans as well, right? So first off, adopt the principle of least privilege. This is going to be one of the themes of this talk in general, which is, again, you should use as little as possible, as little power as possible, as little privilege as possible, because as little information flow as possible defined through workflows, because the more you constrain that, the less things can go wrong. You can use time-bound access tokens, where basically with a particular task, like that personalize an email to John task, I might have a token that then gives me access to John's PII just for that task. And when the task ends, I revoke access to that and I clear all information from that task, period. I remove it, I make sure it's not in memory, etc. In general, using sandbox environments for testing is a way where you can see potentially sort of bad design patterns that are happening or ways that data leakage is occurring. Oh, I see a lot of questions here. Oh gosh, this is a very long question. So Vijay, I'm going to answer your question sort of toward the end of the talk because it's too long for me to read right now. Vignesh asks, I have a use case of curating good alpha data for crypto coins used to signal good time to trades. Could I use the judge workflow to both find and evaluate the alpha? Yeah, sure. Also, good luck with that. Yeah, so the evaluation here might be something like you think that you have a particular trade that you could do, and the evaluator might run some sort of simulation, like a Monte Carlo simulation at heavy cost. If the risk associated with that is very high, I do some sort of simulation, and that gives me like a different estimate of risk, for example, right? I might get some distribution of our potential outcomes, and then we as a group decide, hey, that this alpha looks like it's correctly computed, or whatever this trade looks like it's going to be profitable in a particular way, or not. Yeah, great question. Anonymous asks, what, if anything, is the relation between your discussion and the old rule engines? Yeah, this is a great question as well. So you can think of, some of these workflows feel a lot like, well, like I mentioned, if this, then that, and that feels very rule-based as well. Rule-based systems and the creation of things like knowledge graphs, which are very similar to like thinking about like people call it GoFi, like good old-fashioned AI. Those are definitely coming back, right? Like there are knowledge graphs that Perplexity uses, OpenAI uses for understanding you and other people. Those are built. Those are discrete structures. They have the same combinatorial explosion problems that we had in the 60s and the 70s. Yeah, those are totally coming back. Yeah. Some of the differences here are like with the rule-based stuff, I now have an internal system, that agent, which is dynamically choosing when to sort of execute those compositions of rules. But yeah, they're quite related. And this is actually part of why I'm excited about sort of the AI agent thing that's happening right now, is because some of this is sort of a callback to like the initial attempts to do AI in the late 50s, the 60s, and the 70s, which ran into these brittleness problems, these combinatorial explosion problems. Like I can't store all the knowledge that I have for the entire world explicitly. Now we're able to combine that with like these powerful embedding models and so on, or these models that learn like a world model, an estimate, an approximation of the world. We're able to combine these, and I think it's very, very powerful. It's pretty cool. Great question. A big open question right now is in terms of accountability. And by the way, this isn't just for AI agents. This is also for like traditional machine learning, right? Like when it comes to a self-driving car not perceiving a human on a bike, for example, as tragically happened in Arizona a few years ago, does that liability go to the developer who wrote the code that trained that vision model? Does the liability go to the car company? Does the liability go to the person who is in the car who potentially should have taken over when they noticed that self-driving wasn't going to pick up the person? Does it go to X, Y, or Z? Does it go to the government? Like, these are questions that are still being sussed out in court. You can try to get ahead of these a bit when it comes to deploying internally. So one is obviously to just establish clear ownership. and sort of responsibility matrices for these agent operations, if you can. I'm not saying that you can necessarily because the law is sort of out there on this still. Keeping detailed records as much as you can, right? Saying, hey, X did this thing and we evaluated this system, and here are the thresholds that we used before deploying it, and this is why those thresholds were practical, and this is, a very low probability event that occurred. Records will help you with that. Detailed documentation will help you with that. So for example, if I'm releasing an open source tool, or if I'm releasing a closed source tool that an enterprise then uses, if I document how it works and if I document potential risks and potential failure modalities in a very clear way that's communicated to the end user, then that might protect me as the developer or the creator of that product from liability and maybe pushes the liability to the person who deployed it. And then obviously with anything in automation, having clear and communicated escalation paths for both incident responses as well as for incident responses. So a couple more slides and then we'll just drop to Q&A. So here, these are obviously my opinions. This whole thing is my opinions. But here's where two things that I see happening this year. So one is sort of some of the questions that were asked, like guardrailing these systems is strictly harder than guardrailing like traditional LLM systems. These sort of content-based guardrails are still going to be table stakes, right? Like, is step A or step 12 in my workflow, is it generating toxic content? Like, yeah, you should still be monitoring that for sure. You need to start doing guardrails over the structure, the workflows themselves, right? That's that combinatorial explosion that I talked about, where errors can propagate and you need to be watching over them. And enterprise governance, I think, is going to start to require sort of workflow selection as a form of guardrailing these systems to help with liability, to help with access control, and so on. So I could see actually internally, if enterprises start to deploy these agentic systems, and I believe they will, maybe there's some sort of internal set of workflows that you can choose from that have particular use cases that are pre-approved and particular risk profiles and so on. And then you're able to get a general risk estimate for the entire agentic system by way of leaning on your enterprise's, pre-approved workflows or whatever. And cost and latency optimization are going to become a thing again, right? So there's been so much competition in just the pure LLM space, right? Between the closed source, well-capitalized companies and the open source, well-capitalized companies, right? Like DeepSeek and Meta are pushing out tons of open source, and OpenAI and Google and so on are pushing out tons of closed source. And cost was really less of a thing for the end user, sort of coming into mid 2024. Now we have these multi-agent systems which might be calling hundreds or thousands of LLMs, and they have to do it also not entirely in parallel. So that can cost a lot, but also that sequential calling is going to increase latency potentially a lot as well. So I think we're going to see a lot of optimization of the graph structure themselves. So it's going to be optimization of workflows, the structure of the workflow, as well as optimization of the composition of those workflows, which creates a larger graph, right? And that graph happens over time. So we get an estimate for how sequential it has to be, how long it might take, how expensive it might be, and so on. So the graph theory nerd in me is excited about that, because now we can start thinking about these really cool discrete structures when we're trying to decide that Pareto frontier of like cost versus potential performance versus like latency. So I think we're going to see a lot of academic work in the optimization of these workflow compositions. And coming back to some of the earlier questions, this is how I'm going to end this webinar, and probably how I should end every webinar until the end of time is, if you believe that multi-agent systems are basically this embodiment of the traditional AI paradigm as defined by like the late 50s, which I kind of do, you want to make sure that you're using just as much power as possible for that cost reason, for that risk reason, for that explainability reason, and so on, like we discussed. So A, do you even need to use Gen AI, or can you just call like an API, like I was talking about with the ticker symbol lookup? Do that. But B, maybe just lean on a traditional LLM. If that's not enough to solve your problem, if you need all of this reflection, if you need to have this sort of like calling out to humans to get feedback and so on, maybe just sit with single agent systems. And if that's not working, maybe start moving into multi-agent system land. But this is very, very early days for some of this stuff. And keeping control of these systems and evaluating these systems is very, very early days as well. So balance that risk versus reward, as always, in anything machine learning based with agents. Great. So last 15 minutes or so, if we want, we can drop to Q&A. Thank you all for coming. So I will now read this long question from VJ. I was planning an agentic workflow for our data ingestion pipeline that involves a lot of cleanup and transformation. I was planning to use standard semantic rules to achieve these, but where the LLMs can come in handy is when we run into unknown inputs for which we don't have rules, and our pipeline will run into errors. Yeah, that's true. Piping these errors to automatically handle the new data was one of the use cases I was considering. Does this align with what you had previously mentioned about using an API to handle deterministic workflows and use LLMs more cautiously? Yeah, that's right. So if I were to summarize this question, the idea is that we have some sort of data ingestion pipeline, and we're expecting some distribution of data, could be some dates, could be names, etc. And I have good, traditional natural language-based rules to define, or even regexes, right? Like regular expressions for dates, to say, hey, this is a date, this is a person's name, this is a city name, and store them as such. And then I'm going to have something which says, hey, none of my rules are actually firing with high enough confidence. What do I do next? Yeah, I would say like you can call out to a foundation model and try to get some sort of estimate from there. What's going to come back is one of two things, right? One is going to be, it's going to say, hey, this should be labeled date, right? Or this should be labeled name, or this should be labeled one of the labels that you already expect in your rule-based system. Or it's going to come back with some other label that's not actually in like the system that you're expecting, right? And you have to decide what to do with that, right? You could have some unknown label or like other label or whatever that you just dump everything into. Or you could have that fail fast and say, hey, like we don't accept this. This is out of distribution data, like flag an error, raise an exception, whatever. Yeah, you could totally use a Gen AI based approach to doing that. Yeah, good question. Other questions? Go on one. Go on twice. Well, as always, feel free to reach out to me. I'm just john@arthur.ai, john@arthur.ai. Very chatty. So thank you for coming again, and have a great 2025.